Well, we've certainly had some unusual weather around the country, including some snow in Phoenix and in Malibu Beach even over the last weekend. It ruined the citrus crops in California. Now in New Mexico, we went from drought conditions last year at this time, and then we had a record summer rainfall, and now we're having all the snow this winter. Now, joining us, someone that knows about weather and has seen this from all around the world is Mark Ivey. Mark Ivey, excuse me. He's a weather scientist from Sandia National Laboratory, and he studied the weather from Africa to Alaska, right?
That's right.
Tell us a little bit about what you do, because it's fascinating to me.
So I work for Sandia National Labs. I work on a small team there, and we're part of a large Department of Energy program funded through the Office of Science and Department of Energy. And we're trying to answer one of the big questions in climate models. When folks look at, have run climate models against each other, they found they produced very different answers. And one of the big uncertainties, or the major uncertainty in those models, is water vapor and clouds. People recognize carbon dioxide and methane as a greenhouse gas, but the predominant greenhouse gas in the atmosphere is water and water vapor.
So let me slow you down there. So what you're really measuring is that you want to really kind of focus in on the cloud cover in these different parts of the world. So you've been to some extreme places. As a matter of fact, we have a lot of pictures. Go ahead and run through these. A lot of these are from Africa, and then we also have some from Barrow, Alaska, where you have sites. You have sites, and you guys go out there, and then you measure these sites. You measure the cloud cover. You measure what's going on in there. Matter of fact, there's some of the sites and some of the measuring equipment right there, correct?
That's correct, yeah. So we have 3 fixed sites that measure things in the atmosphere that are important to understanding climate. And then we've got a mobile site that is just wrapping up an experiment in Africa. It's moving to the Black Forest in Germany next, and from there possibly to China. So we're trying to improve how we understand clouds and how we can represent clouds in the big models.
And you're doing this because this is not for the models that I use on a daily basis, right? We use the 24 to 48-hour outlooks. We're looking at the short-term forecast. This is something that you want to go out 50 years, 100 years, right?
Exactly. So these models divide the Earth, the entire Earth, into small grids. Small, I mean 100 kilometers on the side. Then put in initial conditions and run it forward, say 50 or 100 years. And how's it coming out? Is it working? I mean, you getting some results that you think you can sink your teeth into? You know, we're getting better and better. We're answering the questions one by one. Clouds and water vapor is still a big uncertainty, and I think that's where we're able to make a contribution.
Now, this year we're experiencing the El Nino, and we're seeing the effects of that. And you actually have equipment out over the Pacific that measures as well.
Yeah. So we've got equipment on some small islands near Australia, and this is a chance, one of our chances right now to catch a big ENSO event. They call it the El Nino Southern Oscillation, when the pressure flips in the Pacific, and we see something different. Yeah.
Fascinating work. I love to talk to you. Maybe we can get you back in here. We can talk more about this. I appreciate it. Thank you.
Thanks,
Mark Ivey from Sandia Labs joining us. We'll have more on the weather here locally, not 100 years out. We'll just go about 7 days out, so don't go away. That's coming up.